Hi everyone, welcome to today's webinar, Enhancing Your Environmental Health and Safety Strategy with IoT Technology. I'm Paul Collins and I'm a member of the European Application Engineering team in Donaldson's Industrial Air Filtration Division, and today one of your presenters along with my colleague Brent Nelson.
Hello everyone, I'm Brent Nelson, Global Product Manager in Donaldson's Connected Solutions business.
Today I'll be speaking to you about the 3 E's of industrial air filtration, and then I'll pass it over to Brent, who will discuss how you can enhance your EHS strategy on your local exhaust ventilation systems with IoT technology. When it comes to local exhaust ventilation systems, there are 3 terms that we like to make people aware of, and they are exposure, efficiency, and emission. Exposure relates to the amount of particulate your employees are exposed to from their manufacturing process. Efficiency covers the status of the LEV system. Is it doing what it's supposed to do, collecting the particulate and then filtering it from the airstream? And finally, emission, which is all about the quality of the air that is actually coming out of the exhaust stack. For exposure, the goal is to maintain a given air quality level for your employees. There are key variables that can be used to check the status. For example, the airflow that it is designed to meet. Efficiency of the LEV system is the key to achieving either target exposure levels and/or emission values. Trends over time can confirm that you're maintaining stable performance within your LEV system. But if you're not, then you want to make sure that you have some sort of notification to indicate its declining performance. For example, if you're returning your filtered air inside and you have an upset condition such as a filter or a bag leak, those could lead to overexposure issues. If you're discharging the filter air outside and you have the same upset condition, that could lead to excessive emissions. In terms of emission, the goal is to keep the value below the regulated limit, whether it's total particulate, PM10 or PM2.5. Monitoring the status of your system over time can help you anticipate maintenance and predict if there are any issues developing. When it comes to exposure, you want to identify what's in your airstream. Knowing the particulate, whether it's filterable particulate or a gas, will help identify the level of control that is needed. This will impact on system design details, such as the hood or the airflow that's required to remove the hazard from the employee's working area. Also, you want to make sure you recognise the impact of design changes to a system that's already in place. For example, it might be a good idea to add a secondary or a HEPA filter to minimise the risk of excessive emission. However, adding this level of additional restriction will impact the overall volume in the system and could reduce the capture velocity and thereby increase the exposure levels of the employee. Performing ongoing monitoring of your system, such as maintaining the design flow, tracking the filter life and the filter loading, and detecting the early onset of filter leaks, will help monitor the overall system and its status, and thereby reduce the risk of unplanned operational downtime. There are different regulatory requirements for different parts of the world, and clearly performance of the LEV system needs to satisfy local requirements. A contaminant usually has an official published indicative occupational exposure level, which is based on the severity of the hazard and set to protect the health of workers. Occupational exposure levels is given as a concentration in clean air averaged over a specified period of time, referred to as a time-weighted average. 2 time periods are generally used: long-term exposure limit over an 8-hour period and short-term exposure limit over a 15-minute period. Details can be found in official documents. 2 examples are EH40 workplace exposure limits in the UK and TA Luft in Germany, and similar documents exist for other countries. When it comes to the efficiency, you want to make sure your system is performing as per design. Do you want to verify the air volume is meeting your design goals? You can do this by recording static pressure at key locations, such as your hood or in your ducting. For the collector, it's all about filter status. The differential pressure will help indicate the life of the filters and help protect and create preventative maintenance schedules. Monitoring cleaning systems will ensure that you are only using compressed air when you need to. For emission, the big question is what about if you're returning the air into the building and have an upset condition such as a filter break? Are you concerned that you could be exceeding employees' exposure limits? Do you need additional equipment such as a secondary or HEPA filter? If you're exhausting near to the atmosphere, you'll also have the environmental impact, and you'll want to make sure that you're not exceeding any of your permitted values. So now I'll pass over to Brent.
All right, thank you for that excellent overview on the 3 E's. Just a reminder, I'm Brent Nelson, Global Product Manager in Donaldson's Connected Solution Group, and we're going to talk about how you can enhance your EHS strategy with IoT technology and applications built on IoT. You're probably familiar with the term IoT. My guess is you've heard lots of sales presentations and other things around IoT. This is not going to be a technical discussion about IoT because IoT at its core is really just about collecting data and building applications around it. What I want to talk about specifically is how that data and the applications built around it can help you in your strategy for maintaining a healthy and safe work environment. So when we look at the lifespan of a dust collector, it starts at the design phase. You're designing the dust collector for a specific application in your plant. It then gets installed. It's going to run for a long time. It'll go through several maintenance cycles. And then at some point, you're going to do a verification that everything is still working correctly. And that verification may be due to a regulation or compliance needs that you need to prove, or it might be due to just internal processes and procedures and safety requirements. Based on that, you may go back and modify the design and go through the step again. So when we want to make sure that our dust collector is working the way it's designed and that we're within compliance of all of our regulations and our internal processes and procedures, we're typically going to do that anytime we install the dust collector or make a design change to it, and then when we get to that verify step at the end. And that verify step might be every few weeks, every few months. It might be up to a year, depending on what regulations you're required to meet or what your internal processes require. Which means that for a lot of the time, when the dust collector is going to spend most of its time in that run maintain mode, you're really in a risk area where you aren't sure if that dust collector is still working within its design parameters, or if there might be a problem that could be affecting the exposure of your employees, it could be affecting the environment, or you might be running outside of compliance. And really this is the challenge for EHS people, is understanding in between those two compliance verifications, is it still working normally? And there's very little data that you're probably getting today to tell you that that dust collector is working normally. And what you don't want is to find out when you get to that compliance verification that you fail. Typically, there's major repercussions to that for a company. It could be it could mean that you're going to get more stringent regulations and more stringent inspections in the future, or it could be something even more severe, like you're forced to shut your line down or even your factory down until you can prove you're within compliance. So there's a lot of negative things that can happen to a business if you fail that compliance verification. But now if we look at this overlaid with a connected filtration service on top of this, again, using IoT to capture the data from your system during its lifespan. So it starts on the left with capturing data from the system. So from the moment this type of service is installed, you're going to start capturing data from it in near real time. That data is going to be stored and accessible in a cloud or some other database, and it'll be there over the history of the device, so you can always go back to that data if you need it for any type of compliance verification, or even if you need to use it to do optimization or additional engineering around your product. But the most important part really is in that risk area where we've got monitoring and alerting. So now you're not blind to how the system is working. You're getting data from the machines. You're getting alerts if the machine is no longer working within its design parameters. So you can proactively address those concerns before you get to an official compliance verification. More importantly, before you potentially expose your employees to increased exposure, or you've had elevated levels of emissions into your plant or outside into the environment. With the goal being you can actually eliminate that risk area in the middle. Now, we want to note here that an IoT solution can really only monitor a properly designed system. It's not going to overcome if the dust collection system wasn't designed right, or if the application has changed and it's no longer sufficient for what it's doing. But when you know you've got a properly working system, it will tell you if it starts to deviate from those parameters. So as an example of this, of an IoT solution, we recently released our IQ Connected Filtration service here at Donaldson. And this is just an example of what a type of service like this can mean. And when we're done talking about this, we'll go back to Chrissy's discussion of the 3 E's and talk about how we can affect each one of those parameters positively with this solution. So I don't want to spend a lot of time just talking about the solution, but there's a cellular gateway that gets mounted to the dust collector. It has embedded sensors and connects to external sensors, captures data about your dust collector, passes that over cellular to our Donaldson Cloud and our IQ application, where the data is presented to you, the user, and you can go in and see how your dust collector is performing. You can trend historical data. You can export that data for compliance purposes, and then you can get alerts when something is outside of the normal parameters. So if we think of this a different way and look at the data coming up from the dust collector, pushes up to our cloud, there we have our dust collector expertise built into the cloud, so we're applying analytics to that data and driving insights to users on your site, and that can be the EHS professionals, it can also be maintenance managers, plant engineers, anybody who has responsibility for making sure that dust collector is working properly. You can get that data in a variety of ways. There's an online dashboard that, because it's web-based, it can be accessed from anywhere. You can look at it from home if you want to. You can look at data from plants that you're not at if you have responsibility for what's going in multiple plants. You can also get real-time alerts when something's outside of its normal threshold. And then you get weekly reports that will show the status of your dust collection. Again, all that's driven to the people at the facility so they can take the proper actions if maintenance or any other intervention is required at the machine. All right, so now let's go back and talk specifically about the 3 E's and how IoT can change the experience and the understanding of how these things are working in real time. So when we start with exposure, really the key to understanding exposure risk is to understand your airflow. So airflow ensures that you've got proper capture velocity at the hoods. It makes sure so you're pulling that particulate away from your workers. It also makes sure that you've got sufficient airflow through the ducts so you're not getting particulate settling in the ducts, which is a potential fire hazard. So when that airflow decreases, that's the time when you want to take a look at what's going on with that dust collector. It's something that happens very common as filters start to age and it's harder for the fan to move dust through. You can get lower airflow, which causes those exposure hazards that we've talked about. You can also have problems when airflow increases. If you do have a process that creates sparks, it becomes more likely those sparks can be pulled into the system where you've got the potential for a fire hazard. And the excessive airflow can also cause particulate to hit the filters at an excessive speed, which causes them to embed in the filters. And that's going to cause premature filter end of life because they can no longer be cleaned with the compressed air. Now, reading airflow real time in an IoT solution is a little bit challenging. Typically, when we think of airflow, we think of total air volume, or CFM, for most people. And that's typically done by a manual measurement, usually with a pitot tube or some other type of sensor. It usually requires taking multiple data points inside the ducting and doing a calculation, converting the velocity to total volume based on duct size. So it's something that's very hard to do in real time with a connected solution. But one thing we can do relatively easily is track relative airflow inside the dust collector. And that's done by reading the static pressure on the dust collector inlet or the dirty side of the dust collector. And the static pressure is influenced by the air velocity coming through that ducting. On a system where you're not changing dampers or there's nothing else that's changing, the only thing that's going to cause that static pressure to go up and down is a change in the air velocity. And this is a very easy thing for us to measure with a connected solution because we're just reading a pressure sensor. So once you can establish a baseline that you know where you've got good airflow, it becomes very easy to set alarms to know if that airflow is rising above or below a normal threshold. So there's a fair amount of math I just talked about in technical details, but I think it helps to look at a real-world example. So this is from an actual customer site who's using our IQ solution. That we pulled this graph from back in January. And so you see two lines on this graph. The red line is the differential pressure, and the blue line is the relative airflow we were just talking about. So the first thing you notice on this is the red line, the differential pressure is increasing during the day. And that's because in this case, this customer is using downtime cleaning. So they're not cleaning the filters during the day with compressed air, and you can see that it's naturally rising throughout the day. Then we see the dust collector is shut down, downtime cleaning occurs with the compressed air, and then we see that when they start it up the next day, the next morning, that differential pressure is returned to a normal level. Now, when we look at airflow, we see that that's naturally dropping during the day, which makes sense. As those filters are plugging, the airflow is going to start dropping throughout the day. And at the end of the shift, just before you shut off, you can see it's roughly dropped about 20% from where it started the day, which is just around the threshold where we would recommend sending an alert. So if I was looking at this as an EHS professional, I'd have a few concerns. Primarily that what happens if we added a third shift and we didn't have time to do that downtime cleaning? What's naturally going to happen is that differential pressure is going to start to rise and that relative airflow is going to continue to go down. And that's creating a potentially hazardous situation where I might no longer have enough airflow to pull that particulate away from the capture points, exposing my customers to increased particulate and potentially having dust settling in my ducting. All right, so moving on, our second E, efficiency. So efficiency is something that's really difficult to monitor, even with manual measurements, to really determine what's the true efficiency of your dust collection system. It's also something that's extremely difficult to monitor with any type of connected solution. There's a lot of factors that influence it, airflow and air velocity, how the system is designed and balanced, and what your particulate levels are going through the system. So what very often regulatory agencies will use as a proxy for efficiency is they'll look at differential pressure, which is a relatively good term for determine, or a good way to determine how efficient it's working, because high differential pressure means you've probably got reduced airflow through the system, as we just showed on the last graph. A low differential pressure might be an indication that you've got a leak or a tear inside your filter. So either one of those conditions are something that would require additional attention. So very often as part of an air permit, factories will have to present their differential pressure data to a regulator to prove that they're operating within the limits of their compliance. So what we see at a lot of customers is what you see on the picture on the left. Some kind of sheet that's getting filled in daily or maybe multiple times a day. Typically there's a pencil taped to the sheet and somebody's manually entering those values, and then on a Friday or at the end of the work week, somebody's capturing those papers and they're manually typing it into a spreadsheet. So you've got a process that has a lot of opportunities for error, whether it's if somebody forgot to write the data in, or they wrote it in and it can't be read, or the person manually typing them into a spreadsheet mistypes them. And being that all this data is required by compliance, we don't want to have a lot of steps in it that are prone to human error. So now when we replace that system with a connected solution, now we're automatically collecting that differential pressure in the system. It's being stored for historical purposes. It can go back and be viewed and graphed. And then with one click, you can export that data to a spreadsheet. So as long as you have a properly working sensor, you really have a foolproof way to capture your differential pressure data. And if you look at the way that regulatory agencies are moving, especially in other industries, they're moving away from allowing manually recorded data as a way to prove you're in compliance because of the potential errors of it and because that data could be falsified in some cases. One example would be in the trucking industry. If you're aware, they've moved completely away from paper logs. If you're a truck driver, you can no longer manually write in your logs. It has to be electronically captured from your truck. And that's because that proves that they're actually in compliance and they're not cheating the regulation. I think we'll see more and more compliance agencies demanding that that data is automatically captured and not through a manual process. All right, and the last one to talk about is emissions. So emissions is fairly simple compared to efficiency, is you're really just looking for the amount of particulate that's coming out of that discharge duct, either back into your factory or outside into the environment. There's a few ways to measure it. Typically, this is done by different manual measurements done point at time, either be a visual opacity check or it could be tested during different tests using different test setups or sensors. There are sensors that can be installed and read in real time. One is typically called a broken bag. A broken bag is usually going to tell you if your emissions level is good or bad. It will give you an alert when it's gone up significantly from the baseline. Where a particulate trend is a little bit different, that's actually giving you an actual trend showing if your emissions are going up and down in real time. The Cadillac really of the system is the continuous emissions monitoring systems. These are more complex systems that are specially designed for monitoring emissions where you really have to tightly control what's coming out of that stack. Now for a connected solution, we use a trend sensor. And the trend sensor really is a good mix between an extremely expensive continuous emission monitoring system and stack testing, which can only be done on a periodic basis. A trend sensor, when you set a good baseline for it, knowing that you've got low levels of particulate inside your ducting, will tell you when that trend is going up or down and will send alerts to maintenance people when that trend is increasing, hopefully so you can take early action before you have a catastrophic filter failure and you've got a lot of particulate that's going either into the environment or back into your factory. So here again is an example of some emissions data that's coming out of one of our customers. This again comes out of our IQ application over a few day period. So you see this one's gonna bounce up and down a little bit due to pulse cleaning and other things that are going on. But you can see on the right there, I've kind of tied in where we see the baseline value of this when it's running. And you'll also see peaks again based on when you're doing pulse cleaning. In this case, the peak's at about 3.9 times the baseline, which is still okay. Typically, industry recommendations are to set alarms so you get an alert when it gets to 5 times the baseline and then a second alert when it gets to 10 times. But this is something that typically has to be tuned per your process and run for a while to understand where you should get alerts so that you are alerted when problems start to arise without getting nuisance alarms. So in summary, successful dust collection requires effectively understanding, controlling, and monitoring the 3 E's of industrial air filtration, and an IoT monitoring solution like IQ to enhance your efforts. We've talked about a lot of benefits of using a solution like IQ, but a few of the key ones are monitoring relative airflow to help manage exposure risks, automating data capture for efficiency compliance reporting, and tracking emissions levels between verification intervals.